Welcome or welcome back at C-Square. In this lesson we will talk about um, parallel lines and transversal. Okay, you see here two pictures, and on the first one here we have two line M and N, I'm sorry, and this line that cuts both of them, which we call it a transversal. On the second picture, these two lines M and N, you'll see them later, are parallel lines. Sometimes you're gonna see something like that on your picture, which means these two lines are parallel lines. This is the transversal. And I said here, in either case, line T forms 8 angles. And you see them here, 1, 2, 3, 4, 5, 6, 7, 8. Now, angle 1, 2, 7, 8 are called exterior angle. Why? They are outside of these two lines. Angle 3, 4, 5 and 6 are called interior angles. They are between these two lines. Now you notice angle 1, 4, 5 and 8, this one here, are on the left side of the transversal in this case, while the others 2, 3, 6 and 7 are on the other side of the transversal. So saying this, we can go and define some angle, and the first one you see here, we call them consecutive angle. And if you notice, the definition of consecutive angle is that interior angles like 3, 4, 5, 6 that are on the same side of the transversal. So that tells me I'm gonna match 3 and 6. You see, there are interior on the same side, and 4 and 5. That's you're gonna see in my next thing. Okay, angle 3 and 6 are consecutive interior angle. Angle 4 and 5 are also consecutive interior angle. My next type of angles are what we call alternate interior angles, which are non-adjacent, so they are not one next to the other one, interior angles that are on different sides of the transversal. So which one are interior angles? If you remember, again, 3, 4, 5 and 6, but we want non-adjacent. So that means 3, not 4 because that will be adjacent, and one of these 5 and 6. Which one? 5, because you notice 3 and 5 are on different side of the transversal. One is on the right side, the other one is on the left side. The other pair obviously is 4 and 6. So 3 and 5 together, 4 and 6. This is the second pair. Alternate interior angles. Let's take a look to the next one, which we call them alternate exterior angle. So if you remember, which angles were exterior? 1, 2, 7 and 8. But alternate exterior angles are non-adjacent angles, so kind of the same idea like the previous pair, that are on different sides. So if I say 1, I hope you're gonna say 7, because these two angles are exterior angle. They are not adjacent, and they are on different side of the transversal. Which one is the other pair? If you said 2 and 8 in your mind, that is correct. These are the two pairs that we call them alternate exterior angle. My last type of angles that I'm gonna have it, and this is the last one in this case for this type of lines, we call them corresponding angle, that are on the same line, on the same side, I'm sorry, of the given line, transversal, and they are on the side of the transversal. So let's see which one are those. Are on the same side, and they are not. They are on the side of the transversal. So 1 and 5. It's the first set of corresponding angles. You notice they are one interior, one exterior, and on the same side of the transversal. I think that is a better definition than what I said here. Do we have another one? We have 2 and 6. Again, one interior, one exterior on the same side of the transversal. Okay, so I probably will change this definition. Then we have, what else do we have? More? Of course we do have. We have 3 and 7. One interior, one exterior on the same side of the transversal. And we have one more. So this is the one where we have 4 pairs. 4 and 8. The other one, there were only 2s. These are what we call corresponding angle. Let's now see an example after we know the name of these angles. Use the diagram below, classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding or consecutive angles. So let's take a look at the first one. 1 and 5. If you notice, 1 and 5 are right here. That tells me right away this should be the transversal, which I'm going to call it T. And now looking to these guys, we notice one is interior, one is exterior, and they're on the same side of the transversal. So 1 and 5 are corresponding angle. Let's go to B. We're looking now for angle 2 and 8. 2 and 8. Okay, again, this is the transversal T, and we notice both of them are exterior angle, right? They are not between the other two lines. Let's call them A and B. And one is on one side of the transversal, the other one is on the other side. So I think we have a name for this type of angles. Even if you say alternate exterior, that is what we have. Okay, let's move to the third one, to C, where we have angle 4 and 6. Again, what do we notice about these two angles? First of all, we should notice there are between A and B, so they are interior angles. And then we notice they are on different sides, 4 on top of the transversal T, 6 on the bottom. So these are what we call alternate, because they are one side. Each one is on a different side, alternate. Interior, because they are between the lines, angles. Okay, let's go to the next part, which is part D. We're talking about, and let me erase some things here. Let me erase all this marking. And now let's take a look for angle 4 and 5. What do you notice about these two angles? They are interior angles, right? And on the same side of the transversal. This angle, we call them consecutive interior angle. There is another name you may hear for this angle, which I should mention, same side interior angle. In case you hear it, means the same thing. Now let's take a look to part E. I will say not this one, E. And we have angle 3 and 7, 3 and 7. I think we met this type of angles. Those angles, 1 is interior, 3 is between A and B, 7 is an exterior angle, and on the same side of transversal, bottom of the transversal, T. Those are what we call corresponding angle. So very similar to A, the same thing, the same type of angles. And we have one more. This F here. What do we have here? Angle 3 and 6, which is this angle and this angle. Oh, they are like 4 and 5. We had that before. They are on the bottom now of the transversal, on the same side of the transversal interior. So how we call those angles? Those angles, we call them consecutive interior angle. Or same side interior angle. Remember we said that here, same side interior angles. Okay, so now let's take a look to the next part. Sometime I said you need to work with multiple lines. Like you see here, we have A, B, M, N, N, and we need to identify the transversal. That's very important. Identify the transversal first, related to each pair of angles, then classify the angles. So let's take a look to A. On A, we're looking to angle 2 and 5. 2 and 5. Which one? A, B, M, or N is the transversal? Obviously, for sure, it's not N, and doesn't have any connection with 2 and 5. The transversal will be M. Okay? And looking to these angles, they are both interiors between A and B in this case, right? And on the same side of the transversal, so they are what we call consecutive interior angle. Okay, now let's go to B, where we have to look to angle 5 and 9. 5 and 9. Oops. What do you notice here? The transversal now is not going to be M, it's not going to be N, it's not going to be A, it's going to be B. So very important, first identify the transversal. And now we can take a look. This is the transversal B. 5 and 9 are on the same side of the transversal. 1 is exterior, 5. 1 is interior, 9. How do we call those guys? Like that. We call them corresponding angles. Okay, remember those on part A, consecutive interior angles, we can call them also same side interior angle. Okay, let's go to part C, where we have to look to angle 12 and 14. 12 and 14, which one is the transversal now? Now the transversal will be N. And now we're looking, these two angles, 14 and 12, are between A and B, so they are interior angles. And one on one side of transversal and the other one on the other side of transversal. And we call these angles what? Alternate interior angles. Let's go to part D. Which says angle 7 and 9. 7 and 9. Oops, let me erase that here, too much. Maybe I should do more like that. 7 and 9, these two angles. These two angles, if you notice, they are having the what transversal? Transversal B. One more time, the same transversal B. Both of them are between M and N, interior angles, one on one side, one on the other side. Another pair that we can call them alternate interior angles. We have two more, so let me erase this picture to get a little bit more clarity, I guess. And let's move to part E, which says angle 2 and 14. Angle 2 and angle 14. Okay, which one is going to be the transversal now? Now the transversal will be A. And if we look in now, angle 2 and angle 14, they both of them are on the right side, if you want to call it like that, of transversal A. One is exterior 2, one is interior 14. How do we call those angles like that? One interior, one exterior on the same side of the transversal, those are called corresponding angle. And we have one more, F. Let's see, F here, angle 11 and 13. 11 and 13. Which one will be the transversal? Now the transversal will be N. And if we notice, 11 and 13, looking to the transversal N, A and B are the other two lines. They are not between A and B, they are outside of those two lines. So they are exterior angles, one on one side of the transversal N, the other one on the other side of transversal N. We call them alternate exterior angles. So that's it. When you have more than 3 lines, be careful, I can say that. On my next part of the lesson, we're going to move to parallel lines. Like I said, this is another type of situation when we have two parallel lines that are cut by a transversal T. Now, the next thing is to say some properties we have in this case. And we're going to start with this first property of consecutive interior angles. Do you remember which one were the consecutive interior angles? If you remember, it was 3 and 6. And which one is the other one? 4 and 5. Very important to match them like that. If you match them like that, okay, 3 and 6, 4 and 5, you notice these two angles are not congruent. These angles are supplementary. So look at here what my statement says here. The measure of angle 3 plus the measure on angle 6 equals 180. Okay, that's what this says here. Very similar about the other pair. Angle 4, the measure of angle 4 plus the measure of angle 5 equals 180. So you can simply see 3 and 6 are not the same. One is obtuse, 3 in this case, 6 is acute. They are not congruent. They are supplementary, in case you do not remember the property. The next angle we have alternate interior angle. Which one were those alternate interior angles? If you remember, 3 and 5. Now let's take a look to 3 and 5. How do they look? Both obtuse. In this case, the other property for parallel lines and transversal, congruent. And obviously we have another pair, 4 and 6. If you notice, these two are acute in this case. Again, congruent. Okay, so look at here what I'm gonna write. Angle 3 congruent with angle 5. Or you can say measure of angle 3 equals with measure of angle 5. Either statement is good. Angle 4 and 6 are congruent. That means they have the same measure. Okay. Of course, this picture helps us to identify the property because the pictures are pretty accurate. Alternate exterior angle. If you remember, we had something like that. Which one are those? 1 and 7. Do you notice both obtuse? Oh, that means they are congruent. What about the other pair? 2 and 8. Both acute. Oh, again, they are congruent. I'm going to write here. Angle 1 congruent with angle 7. Or if you want to go with the measure of angle 1 equals the measure of angle 7. Angle 2 congruent with angle 8. Or the measure of angle 2 equals the measure of angle 8. Alternating exterior angle, congruent. And the last set, if you remember, we had is corresponding angles. And these are what? 1 and 5. Both obtuse, so that means they are congruent. Do we have another set? Yeah, 2 and 6. Both acute. They are congruent again. Do we have another set? 3 and 7. Congruent again. And the last one, 4 and 8. Congruent again. This is the only type of angles where we have 4, right? So angle 1 congruent to angle 5, or the measure of angle 1 equals the measure of angle 5. Angle 2 congruent to angle 6, or the measure of angle 2 equals the measure of angle 6. Angle 3 congruent with angle 7, or the measure of angle 3 equals the measure of angle 7. And obviously the last one, angle 4 congruent to angle 8, or the measure of angle 4 equals the measure of angle 8. Okay, so now having all this, we can do some problem. Let's take a look to this example. Use the diagram below where the measure of angle 4, this guy here, is 32. Find the measure of angle 6 and 8. Let's start with 6. And also need us to justify the answer. If we take a look to these two angles, 4 and 6, they both acute. The picture here is pretty accurate. By the way, I should have here, these two lines are parallels. Okay, so if you do not remember the property, the picture itself helps you, but these two angles are congruent. Angle 4 congruent with angle 6. We call this what type of angles? You notice this is the transversal T. It helps us because it's just the letter T. But don't trust that. I mean, I can say that. But in this case, line T is the transversal. Okay, so angle 4 congruent to angle 6 because these are alternate interior angles. So now we justify the answer. So now we can write the next statement, which is the measure of angle 4 equals the measure of angle 6. And since the measure of angle 4 is 32, how much is going to be the measure of angle 6? The same, because they are congruent. Okay, so now we can really write a kind of a short proof to come with this idea of angle 6 being 32. But now let's take a look to how we find angle 8. And since we talk about these type of angles in this lesson, I'm going to look to angle 4 and angle 8. These two angles both acute. The picture helps us in this case, so we know they are congruent. Angle 4 congruent with angle 8. However, if we need to justify the answer and sometimes the lines do not help you to see the property, these two angles are what? They are both on the same side of transversal T, on the left side if you want to call it like that. One is interior 4, one is exterior 8. This one we call them corresponding angle. Okay, so ladies and gentlemen, now we have the justification. We can move to the next thing, which is very similar to what we did here. Measure of angle 4 equals the measure of angle 8, right? Because the angles are congruent. Measure of angle 4 is 32, was given to us. So obviously, we know right away that the measure of angle 8 equals 32 degrees. Now some of you may say, hey, but I didn't know, I don't need all that thing. Angle 6 and angle 8 are congruent, they are vertical angles, that will be great. I just want to use what we learned in this lesson. Let's take a look at the next problem where I said, hey, sometimes you need to use some algebraic skill for solving the problem. Use the diagram below where line M parallel with line end. So I'm going to mark this on the picture, and for those who do not know, that's the meaning of this guy here. Find the value of x and the measure of angle 1 if the measure of angle 3 is 5x plus 8 and the measure of angle 5 is 6x minus 12. So we notice 3 and 5 are given to us as expression, and you notice these are the two angles. Again, the picture helps us here, and we notice both of them are obtuse. So I know right away that angle 3 and angle 5 are congruent because the picture helped me. But what will be the name of these angles? They are between M and N. And by the way, again, the letter T help us here. This is the transversal. And 1 on one side, 3 on the right side, 5 on the left side of the transversal T. So those are alternate interior angles. So that means simply the measure of angle 3 equals the measure of angle 5. Now let's take a look. What is angle 3? Angle 3 is 5x plus 8. And angle 5 is 6x minus 12. So now we need to find x, right? That's the first thing. I personally subtract 5x's to get rid of this 5x. Don't forget to do the same thing on the other side, obviously. And we have here 8 equals 6x minus 5x, that is x minus 12. I'm gonna add 12 to get rid of this 12, obviously. Add 12 on the other side. And we have 20 equals x, or x equals 20. So we have the first part of the problem where we did find the value of x, and now we have to find the measure of angle 1. If you take a look, angle 1, this one here, what can you say about this angle? You can say, hey, angle 1 and angle 3 are congruent because they are vertical angles, or angle 1 congruent with angle 5 because they are what? Corresponding angle. So angle 1 congruent with angle 5, and because they are corresponding angle, so measure of angle 1 equals with the measure of angle 5. Can we find the angle 5? Of course, angle 5, if you take a look, is 6x, so 6 times 20, because that is how much x is. 6 times 20 minus 12. So 6 times 20, 120 minus 12, that will be 108. The measure of angle 5 is 108. And obviously the measure of angle 1 now, the one we are asked, is going to be the same, 108 degrees. Okay, and that's it for this problem. Sometimes you will need to work with multiple lines, like in this case we have what? Line A, B, and C. You notice the picture help us. These three lines are parallel lines. We see the arrows, right? That should tell us these two lines are parallel lines. And we need to use this diagram to where the measure of angle 5, this angle 5 here, it's 68, and we need to find these three angles. Let's take a look at the first one, the measure of angle 9. 9 is right here. So looking to 5 and 9, I can see the transversal is obviously this T, and they are on one side of that transversal. But now be careful, this is an exterior angle if we look just to B and C, right? Because those are the two lines I'm looking for, so ignore A in this moment. And 9 will be an interior angle, but they're on the same side. So angle 5 and angle 9 are congruent, and we can see that in the picture also, because they are corresponding angle. So now the measure of angle 5 is the same of the measure of angle 9. So obviously, since the measure of angle 5 is 68, it's given to us, the measure of angle 9 is going to be the same, 68 degree. Okay, let's go to the next one, angle 3. Okay, so let's take a look. Let me erase these things here. Angle 3. Angle 3 is here. Let me change the color. Angle 3 is here, ladies and gentlemen. And let's connect it to what is given to us. Angle 5. Can we do it with angle 9? We can. And again, we look into this triangle again. This is the transversal. And this angle now, both acute, the picture help us to see that. The transversal is line T, one is on the top, one is on the bottom of transversal, if you want to call it like that, both between A and B. So those are alternate interior angles, which are congruent. So I'm going to write here angle 5 congruent with angle 3. I'm going to justify my answer, alternate interior angles. And then I'm going to say the measure of angle 5 equals the measure of angle 3, because that's happened when you have congruent angles. The measure of angle 5, we know it's 68. So obviously the measure of angle 3 will be also 68 degrees. And we have one more in this problem, which is the measure of angle 4. Okay, let's take a look to angle 4, and since we want to be consistent, let's go with angle 5. Any relationship between angle 4 and angle 5. We notice we have the same transversal T. These 4 and 5 to bring us A and B only, ignore C. And you notice both are between the lines, so they are interior angles and on the same side of transversal T. We call them consecutive interior angle or same side interior angle. What do we know about those angles? They are supplementary. So look at here what I'm saying. The measure of angle 4 plus the measure of angle 5 is equals 180. And by the way, the picture helps us. You notice this is an obtuse angle, this is an acute angle. They cannot be congruent because there are only two properties, either congruent or supplementary. Now we know the measure of angle 5, it's 68. So I replace it, and one more step, subtract 68 to get rid of this plus 68. And we finish this problem. We just have to do 180 minus 68, and that will be 112 degree. And that's it for this problem. So you notice this is a good example to see the only two properties we have, congruent or supplementary. On my next problem, very similar, we have multiple lines and we need to find some angles. Use the diagram below where measure of angle 3, this guy here, is 124, and the measure of angle 9, this guy here, is 92. Find the measure of angle 8. So let's start with the first one, angle 8. So if we look to this guy, which one we can go with? Okay, by the way, you notice the line A and B are parallel. So in this moment I'm looking, and if I want to find angle A, the measure of angle 8, I don't really need this one here. I'm just gonna need to get the transversal, and that will be M in this case, right? And these two angles, if you notice, the picture kind of help us, are what? Congruent, right? What will be the reason? They are one interior and one exterior on the same side of the transversal. So in your mind, if you set corresponding angle, that's correct. So I'm gonna say here, angle 3 congruent with angle 8, and again they are corresponding. So the measure of angle 8 will be the same of the measure of angle 3, which is 124 degrees. So I kind of make it shorter here, okay, because they are congruent, they have the same measure. Let's go to the next part, which is the measure of angle 14. So let me erase this guy here, and we're looking now for angle 14. If you notice 14 now, and these two lines are parallels, which of these two angles I'm going to use? Angle 3 or angle 9? Obviously angle 9, because 14 and 9 go with this transversal N, right? And how are these two angles? We don't really have a name for these angles if you look like that. But we can kind of notice, hopefully, that this is an acute angle. Yeah, this is an obtuse. I don't know if you really see that. So they are not congruent. Which one will be the other property? They are supplementary. Another way to see it, angle 14 and angle 16 are congruent. Vertical angles, and 16 and 9 are consecutive interior angle or same side interior angle. So they are supplementary. But I'm going to go short here. I'm going to say the measure of angle 14 plus the measure of angle 9 equals 180. These two angles are not congruent, they are supplementary. This is the second property. So the measure of angle 14 plus 92 equals 180. I'm going to subtract 92 and I'm going to have the measure of angle 14 equals 88 degrees. And again here, maybe that's the justification you want to have. Angle 14 and angle 16 are congruent because they are vertical angles, and then 16 and 9 are consecutive interior. Okay, now let's move to the last part of this problem, where we really have to find the measure of angle 4. So my first thing will be to erase this picture. I'll suggest you to do the same thing. Too many things will confuse you. So now we need to look to angle 4. And again, these two lines are parallel lines. Okay, and so from these two, angle 3 and angle 9, which one I need? I think I'm gonna need angle 3, right? Angle 3. And if you take a look here, I don't even need something fancy. Okay, I'm not gonna use today's lesson for this. Angle 3 and 4, they form a line. They form this line A. They are linear pair. So I'm gonna say here the measure of angle 3 plus the measure of angle 4 equals 180. So Nothing from today's lesson, just something that you learned before. 124 degrees, that is the measure of angle 3, plus the measure of angle 4 equals 180. So let me erase a little bit that m we have here to be sure we understand what that means. So just subtract 124 on both sides. And we have the measure of angle 4 equal 56 degrees. And that's it for this problem. Again, be careful. There are only two relations you can use, supplementary or congruent. Be careful which one you use. Okay. Another example where now we have to use the diagram below where we notice these two are parallel lines. Okay, by the way, this one looks like a trapezoid if you ask, if you're really wondering what's the name of the shape. It really doesn't matter for us in this moment, the name of the shape. And we know here the measure of angle A is 3x plus 24, and the measure of angle B is y plus 25. They don't even have the same variable. The measure of angle C is 4y, and the measure of angle D is 78. Find x and y. Now looking here and noticing these AB and DC are the parallel segment lines, belong to lines, right? I will say AD and BC are the transversal. So now let's match the correct angles. So will be A and D, and they are not congruent, right? If you take a look, these are two parallel segment lines. These are between the lines, interior angles on the same side of the transversal AB. Those are what we call consecutive interior angles. So A and D are supplementary. That's the reason I'm going to write here the measure of angle A plus the measure of angle D is 180. And I think now we can find x, right? We have A is 3x plus 24. D is, the measure of angle D is 78 degrees. And that is equals 180. So now this is an equation. From geometry we go to algebra. We're going to add 24 and 78. And that will be 102. Then we're going to subtract 102 on both sides. So we have here 3x equals 180 minus 102. That will be 78 degrees. And the last step will be divide by 3. So we have x. We finish with x. 78 divided by 3, and that will be 26. Well, we finish with x. Now we need to move to the y. And if you notice, y goes with angle B and also angle C. I'm looking to these two angles now. Let me mark them with a different color. And again, I want to remind you that the parallel lines are these two. The parallel segment are AB and DC. So again, we're talking about interior angles between AB and DC on the same side of the transversal BC in this case. So again, we have what we call consecutive interior angle. These angles also are supplementary. Let me mark them like this. They are not congruent, so that's the reason I'm going to mark them different. I'm going to say, hey, the measure of angle B plus the measure of angle C equals 180. And now the angle B, it's y plus 25. Angle C is 4y equals 180. Now we're going to combine the two y's here. 1y plus 4y, 5y, plus 25 equals 180. I'm going to subtract 25. And we're going to have 5y equal 180 minus 25. And that will be 155. And the last step, divide by 5. And that will give us what? That will give us 31. And that's it for this problem, where we use twice the fact that consecutive interior angles or same side interior angles are supplementary. The sum is 180. Very important to remember this. And let me go to the last example on this lesson. And then I have one more thing. We have these two rays, if you want to call BF and DH. These are parallel rays. Okay, and we know the measure of angle B is 132, measure of angle D 110. We need to find the measure of angle C. So how much is this angle C? So for that reason, you may want to take a ruler and try to do a better job than I'm going to do here. Draw parallel lines with these two given parallel lines, something like this. So I am so sorry for my drawing. Now let's assume this is a parallel line. So what do we know about this angle B and this angle here, which are marked with two arcs? Those two angles are supplementary, because these two angles are what we call them consecutive interior angles. So 132 plus what is 180, or 180 minus 132, and that will be 48 degrees. So that's the way I did find this part of this big angle C. Okay, these two angles are consecutive interior angles or same side interior. Now let's go to the next guy, which was angle D, and this other part of angle C. These also are consecutive interior angles, because we have this line, we did it, and this one parallel lines, and we know D is 110. So how do we find this one? These two are supplementary. This will be 70 degrees. 110 plus 70 is 180. So how much is the measure of angle C now? That will be 48 plus 70, and that will be 118 degrees. Okay, and my last thing in this lesson will be about this theorem that goes with what we learned today, which is called the perpendicular transversal theorem. In a plane, so you be sure you need to be in a plane, not in space. If a line is perpendicular to one of the two parallel lines, like in this case T is perpendicular on A, on two parallel lines, and A parallel with B, then that line T in this case is perpendicular on the second line. That's what this theorem says, which is shown in this picture here. Yeah, A and B are parallel lines, T is perpendicular. We see that 90-degree angle is gonna be perpendicular on this one. Okay, why? Because these two angles are what we call them, what? One interior, one exterior. We call them corresponding angles. They are congruent. If this is 90 degrees, this should be 90 degrees. So now we know these two lines are perpendicular. I kind of verbalize this proof. I'll show you this proof in another lesson. If you enjoy this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.